Welcome to Barcode Library. Here we'll show you how to use our software to read all kinds of 1D and 2D barcodes.
Barcode Library supports QR code, data matrix, PDF for 1.7, code 1 to 8, EAN, UPC, and other more than 20 barcode image recognition in Visual Studio Net application. I've already added Barcode Library, Barcode Reader Library, DLL to the C# console project reference, and installed system.drawing.com and NuGet package through NuGet Package Manager. In this guide, we will try to scan and read the code 1 to 8 barcode text string from these image files. So let's go ahead and go to the program CS file. First, we have to critical using directives at the top. The first one using barcode library.BarcodeReader imports the whole barcode reading library. This library gives us all core classes and static scan functions we need to detect and decode code 1 to 8 barcodes from image sources. The second line using system.diagnostics loads the debug utility class, which we rely on to print all decoded barcode text into the debug output window so we can view scan results clearly after execution. Right after the namespace references, we set up consistent log formatting for each separate image test case. Multiple empty debug.writeline parentheses statements at blank lines to separate result blocks visually, followed by a horizontal divider line and a simple label line to mark each independent scanning task. This neat formatting stops our debug logs from mixing up outputs from different test images. Each scanning task is wrapped inside its own pair of curly braces. This creates an isolated local scope for variables like options and datas, so we won't hit any naming conflicts between the three separate skim blocks. Let's go over each block one by one. The first scope block is for standard code 1 to 8 barcode reading, as noted by the inline comment. We create an optimizing object and pass BarcodeReader.code 1 to 8 into its constructor. This config restricts the scanner to only search for code 1 to 8 symbology, which speeds up detection and lowers the chance of false barcode matches. Next, we call the static BarcodeReader.readBarcode method. We pass the full local storage path of the target image and our predefined optimization settings as parameters. This method returns an array named datas of barcode objects because one single image might contain multiple separate barcodes. We use a for each loop to iterate over every barcode entry stored in the datas array. For each detected barcode object, we call the getMessage method to retrieve the plain decoded text content, then print that text string out via debug.writeline for review. The second isolated block is designed to handle images holding rotated code 1 to 8 barcodes. We initialize the exact same code 1 to 8 focus optimizing as the first test case. No extra configuration is needed here. The barcode library's built-in scanning algorithm automatically detects skewed and rotated barcode regions without extra setup. We run the same read barcode function against the target image, get the array of barcode results, and loop through each entry to output the fully decoded barcode text just like the first block. The third scope block targets a special variant image where the human-readable text label under the code 1 to 8 symbol is missing. We still initialize the standard code 1 to 8 optimization setting with no extra toggles. The scanner logic only relies on the black and white barcode bar pattern for decoding. It does not require the printed text label below the barcode to work correctly. We execute the read barcode method on this image, iterate over all found barcode records, and print out the complete decoded barcode text successfully. Throughout all three test segments, the repeated blank debug print lines and divider separators are purely for log readability. Splitting each image scan into its own code block keeps the code modular, easy to modify, and simple to troubleshoot if any individual image scan returns unexpected results. Now let's run the console application and see the scanned barcode text output. Review of the first scanned barcode image file. This image holds a regular, straight code 1 to 8 barcode with complete standard formatting. By limiting the scanner to code 1 to 8 only, the tool quickly located the barcode region with 0 misdetections. The full encoded text inside the symbol was extracted perfectly, and the program printed the complete readable barcode text with no errors. Review of the second scanned barcode image file. This image contains a code 1 to 8 barcode that is rotated at an angle within the frame. Even without special rotation-related settings enabled, the scanner's native algorithm recognized the tilted barcode bars, aligned the symbol properly, and fully decoded all embedded data. The complete barcode text was captured and output without any garbled or missing characters. Review of the third scanned barcode image file. This image's code 1 to 8 symbol does not have the auxiliary human-readable text printed below the barcode bars. Since the decoding engine only processes the barcode's bar and space pattern, the missing text label had no negative impact on scanning performance. The scanner successfully identified the code 1 to 8 pattern and retrieved the full encoded barcode text as expected. All 3 distinct barcode image files finished scanning with full success. Every code 1 to 8 symbol inside each image was accurately located and decoded, and valid readable barcode text was retrieved from every scanned image without any recognition failures.
Thanks for watching. Subscribe and follow Barcode Library for more barcode tutorials.